So, good morning, and I will teach you environmental studies. So, before that, myself, you should know who am I. My name is Dr. Sharat Kumar Patra, and I have served many government colleges under all universities, and my last posting was at BJB Autonomous College, and I have retired 5 years back. So, now I have been given this opportunity to teach you environmental studies, which is very essential for all to know about the environment, environmental problems, solutions. So, and you should, I will try my best to make you understand the environmental studies. So, that is about my introduction. Okay. So, let us start now. We will start environmental studies. Okay. So, as per your syllabus, first we will cover the unit 1, and in unit 1 the first is the environment. So, we must know what is environment. So, environment means all the living organisms have a specific surrounding or medium with which they continuously interact. So, all the living organisms, they have a specific surrounding or medium with which they continuously interact, from which they derive their sustenance, their living requirements, and to which they are fully adapted. Fully adapted means they have adjusted to that medium or surrounding. So, that is the surrounding is the environment. Now, we can define environment as the sum total of living and non-living components. So, not only living, but also non-living components, influences and events, all the processes, influences, events that are occurring in that medium, and this surrounding the organism. So, that surrounding is known as the environment. Then the components of environment, already I have given you indication, living and non-living parts are there. So, these are the two components, the living or abiotic and non-living or abiotic component. So, abiotic component and biotic component. Abiotic means non-living components, biotic means living components. Now, let us see what are the non-living components, abiotic components. So, this first includes the light. The light means the radiations and energy. The source is mainly the sun. So, light. Then atmospheric gases. Atmospheric gases and the wind. Atmospheric gases and the wind, the air, that the wind. Then temperature and heat flow. Temperature and heat flow. Temperature and heat flow, that also comes under abiotic component. Then water, water, then gravity, gravity, and then topography, topography, then soil. So these come under abiotic components, and biotic components mean the living components. Who are the living? The plants, animals, and microbes. So they come under this, microbes, so microbes means microorganisms, the bacteria, fungi, then plants, you know plants, and animals, all animals including human being, they come under biotic component. So these are the two components of the environment. Then we will go to types of environment. So types of environment we can divide into three categories. One is natural environment, second man modified environment, and third man made environment. So So these are the three categories. Natural environment, these are maintained by themselves. There is no role of man, and these natural environments include the ocean, lakes, ponds, rivers, forests. These are, and grassland, desert, these are the natural environments. So river, forest, desert, lake, oceans, these are the natural environments. Then man modified environments. Man modified, it's clear that man has modified the natural environment, not created a new environment. Man has modified, changed the already existing environment or natural environment. These include the plantations, like this. So plantations means sometimes we are creating social forestry, we are planting plants. Then sanctuaries and the parks. As you know, elephant sanctuary Chandka is an elephant sanctuary. So sanctuary, the animals live freely and we give them protection. So there is some role of man in maintaining the sanctuary. And park, national park, so we can say Nandankanan. So these are man modified environments. We have modified the already existing natural environment. Then man made environment. So man made means it has been created by man and it is under full control of man. Examples you can take cities, towns, crop field, then artificial lakes and dams. So, best example is your city, town, industries. These are the man-made environments. Man has created these environments. So, again we can divide the environment of the organisms into two categories. One is the internal environment and second is external environment. So, internal environment means the environment inside the body of the organism, within the body, inside the body of the organism, and external environment means outside the body of the organism, that is the external environment. Now, if we compare both these environments, you can understand or all we know that the internal environment is stable, it never varies, whereas the external environment is not stable, it always changes. So, internal environment is stable, and our body surface, it acts as an exchange barrier. The materials, energy, all these are exchanged between the internal environment and external environment by the body surface, that is the exchange barrier. Now, so that is about the environment. Now, we will discuss about various types of environments. First is atmosphere. So, we will discuss about the atmosphere. The atmosphere, we can define this atmosphere as the multi-layered So, that is the atmosphere, the multi-layered gaseous envelope surrounding the earth planet. That is multi-layered, not a single layer. That is the atmosphere. It expands up to 1000 kilometers above the earth's surface. Extends up to 1000 kilometers above the earth's surface. It is a reservoir of several elements essential to life. Several elements, like example I can give you oxygen, nitrogen, hydrogen. So, it is a reservoir of these elements which are essential to life. It serves many functions. The important functions now I will tell you. Number one, it filters the radiant energy from the sun. So, whatever light energy or radiant energy coming from the sun, all radiations do not reach the surface of the earth. For example, UV radiation. So, it filters the radiations coming from the sun. Then number two, it serves as insulator to prevent the heat loss at the earth's surface. Heat loss, because if the heat is lost, then life will not be possible on the surface of the earth. It serves as an insulator. As you know, in the winter season we wear sweater which serves as a insulator. So similarly, this atmosphere serves as a insulator to prevent heat loss from the surface of the earth. Then next function is stabilization of the weather and climate. Our weather and climate, these are stabilized, maintained by the atmosphere. Then it also plays an important role in biogeochemical cycle. Biogeochemical cycle in detail we will study later on, but for the present let me tell you what is biogeochemical cycle. It is the movement of matters between an organism and its environment. The same organism from the environment comes to the body of the organism, then it returns back. So in a cyclic manner it continues. That is known as biogeochemical cycle. The carbon, for example, it comes from the environment to the plants, then from plants to the animals, from animals again it goes back to the environment. So in a cyclic manner. That's why it is known as biogeochemical cycle. Then structure of atmosphere. So now the structure of atmosphere. So previously I have already told you it is a multi-layered gaseous layer. Now the different layers we will discuss here. There are 5 concentric layers, 5 concentric layers within the atmosphere, which can be differentiated on the basis of temperature and pressure. So basing on the main criteria of division is temperature and pressure. Now we can see here. So here the temperature decreases, then this is the pause, there is no change, then increases, then again decreases, then increases, like this. So basing on the temperature divided into different layers, temperature and pressure. Number 1 is troposphere. This one, troposphere. So first layer, that is troposphere. The lowermost 12 to 18 kilometers of the atmosphere is called troposphere. You can say it is 20 kilometers. So it is maximum 18, 12 to 18 kilometers range from the surface is known as the troposphere. So that immediately surrounds us, troposphere. This is where all weather occurs, the weather. Then clouds form, the clouds, they also form in this area. And precipitation falls, means rainfall occurs, because there is cloud. So there is rainfall, precipitation occurs. Winds blow, the winds, they blow. Humidity changes, ardrata, what we say, humidity, that changes from place to place, and the atmosphere interacts with the surface of the earth. So that is the troposphere. So most important is the troposphere, because here winds blow, clouds are formed, rainfall occurs. So that is the troposphere. Within troposphere, the temperature decreases with altitude. You can mark here from 20 to say minus 60 degrees centigrade. The temperature decreases with altitude. When we go high up and up, the temperature decreases. And this temperature decreases, that is about 6.5 degrees centigrade per kilometer. 1 kilometer up, then minus 6.5 degree. Another 1 kilometer, then again 6.5 degrees, temperature will be less. So the temperature decreases at the rate of 6.5 degrees centigrade per kilometer. At the top of the troposphere, the temperature decreases to about minus 60 degrees centigrade. You can see this is the 60 degrees centigrade. So at the top of the troposphere, temperature falls to about minus 60 degree centigrade. Another important feature here, there is occurrence of ozone layer. So ozone layer here present, ozone occurs locally, it occurs locally. Some come from natural sources and most due to pollutions. So here whatever ozone is present in the troposphere, they are made locally. Either they come from natural sources or from pollution. About 75% of the weight of the atmosphere is confined to this layer. So whatever weight of the atmosphere is there, 75% of weight due to this troposphere. That means it is the heaviest layer, so it is the bottom layer. And as a result, the air pressure is greatest closest to the ground. What we say atmospheric pressure, and that also decreases exponentially with altitude. That means the pressure also decreases, because the layer decrease, when we go up, higher up, the pressure will decrease. The troposphere also contains 90% of the moisture. So whatever moisture, means water vapor, is present in the atmosphere, 90% present in the troposphere. So 90% of moisture is present in the troposphere, and dust within the atmosphere. It is full of dust, this troposphere. The upper boundary of the troposphere is the tropopause, means there is no change, stable layer. Tropopause, you can see this one. This layer is the tropopause, where the temperature stops falling and stabilizes instead. It remains stable, constant. So that is the troposphere. Then the next layer is stratosphere. So from this up to this, stratosphere. So, this layer is actually the ozone layer that is present on the top of the troposphere as well as on the bottom of the stratosphere, that is the ozone layer. Now, second layer is stratosphere. The region above the troposphere is known as stratosphere, that is the above the troposphere, and it extends up to the stratopause. Here this one is the stratopause, it extends up to this. So, this one it extends up to this, up to stratopause, about 60 kilometers above the ground level. You can see this is the 60 kilometers, 60 kilometers above the ground. The temperature here you can mark. So, here in the troposphere temperature decreases, here temperature increases. So, the temperature begins to increase in this region, it increases. This is due to the heating through the absorption of UV radiations by ozone. UV radiation means ultraviolet radiation. So, here at the bottom there is ozone layer, and the radiation coming from the sun includes UV. The ultraviolet rays or radiations are absorbed by the ozone layer. So, temperature increases, the UV rays are absorbed by ozone layer. So, gradually the temperature increases, here temperature decreases, here again the temperature increases, and the temperature profile reaches a peak around 55 kilometer and is 0 degree centigrade. You can see here this one, it is about 0 degree centigrade and around 55 kilometers, here 55 kilometers temperature becomes 0 degree. So, here it was a minus 60 degree, then it decreases to 0 degree centigrade. The stratosphere is characterized by extreme low moisture, but in troposphere I have already told you 90% moisture of the total moisture. Here very less amount of moisture is present, extremely low moisture, and presence of ozone layer, there is presence of ozone layer. Now, what is the difference between the ozone layer of the stratosphere and ozone layer of the troposphere? Troposphere already I have told you they are local, from natural sources or from pollution, but here the source of ozone is different, formation is different. So, stratospheric ozone is produced when the energy from the sun breaks down the oxygen molecule to oxygen atoms. These oxygen atoms then bond with other oxygen molecules to form ozone. Now, you see this is the oxygen molecule. Now, the solar energy means the energy coming from the sun. It breaks the oxygen molecule to oxygen atoms. These are the oxygen atoms. Now, this oxygen atom combines with the oxygen molecule. O2 is the oxygen molecule and O is the oxygen atom, and it forms O3. O3 means ozone. O3 is ozone. So, in this way in the stratosphere ozone is formed. There is also another process, the NO2 So, here you can see NO2 by solar radiation it separates, oxygen atom is separated. So, NO nitrogen oxide is formed plus atomic oxygen, NO and O. This is known as photo dissociation. Dissociation means separation, photo means light. So, here the solar radiation means the light, sunlight. That is why it is known as photo dissociation. And once the oxygen atom is formed, it combines with molecular oxygen to form O3. So, ozone is formed. So, mainly it is responsible, mainly the UV radiation or the solar radiation is responsible for ozone formation. Now, you can say what is the source of NO2? NO So, NO in the polluted atmosphere it is present. Now, it is converted to NO2. Then NO2 undergoes photodissociation, O is formed, atomic oxygen. Now, atomic oxygen combines with molecular oxygen forming the O3 or the ozone. So, this is how ozone is formed in the stratosphere. So, there is difference in the formation of ozone layer in stratosphere and in troposphere. Then next layer is mesosphere. So, this one, this layer is mesosphere. Above the stratosphere, the temperature again begins to fall. So, here you have marked temperature decreases, in the next layer temperature increases, in the next layer temperature again decreases. So, here again temperature falls and begins to fall up to about 80 to 85 kilometers. You can see here up to this 85 kilometers, that is known as mesosphere. So, temperature falls, it is reduced up to 80 to 85 kilometers, and this region is known as mesosphere. It is mesosphere. The minimum temperature attained here is around minus 90 degrees centigrade. So, here minimum temperature will be minus 90 degrees centigrade. So, temperature is very less here, minus 90 degree centigrade. The temperature decreases due to rapidly decreasing density of air at this altitude, density of the air, because few elements or gases are present here in this layer. So, having low density, so that is the main cause why the temperature decreases. The absence of suitable medium to absorb UV result in the decrease of temperature, because there is no layer which can absorb UV, as here you have seen the ozone that absorbs UV, so temperature increases, and here there is no such layer which can absorb UV, so temperature declines, temperature decreases. Mesosphere is characterized by the presence of negative ions, negatively charged ions, along with free electrons. There are electrons freely available, negatively charged ions and free electrons and hydrated positive ions. So, that is the characteristic feature of mesosphere. Then Next is thermosphere. Next layer is thermosphere. So, now you can see here again temperature increases, temperature is increasing. So, that is the thermosphere. Above the stratosphere, the temperature again, above the mesosphere, the temperature again, sorry, thermosphere. No, next is mesosphere. So, we have completed stratosphere, then mesosphere. So, above stratosphere the temperature again begins to fall up to about 80 to 85 kilometers, and this region is known as mesosphere. Already we have discussed. Here it contains negative ions and free electrons. So, next is thermosphere. Above the mesosphere is the thermosphere. So, above the mesospause, because of every layer you can see, above troposphere there is a tropopause, above stratosphere there is stratopause, above mesosphere there is mesopause. Now, above mesopause is the thermosphere. So, above the mesopause is the thermosphere, which extends up to 350 kilometers above the ground. So, 350 kilometers, there is no limit, it extends up to 350 kilometers above the ground. In this region, temperature has a positive gradient. What do you mean by positive gradient? It increases, temperature increases, positive gradient, reaching the value in excess of 1100 degrees centigrade. You can imagine, that is why it is known as a thermosphere. Thermo refers to heat or temperature. So, it is the heated sphere. So, temperature may reach up to 1100 degrees centigrade at heights above 120 kilometers. So, it extends up to 350 kilometers. Now, above 120 kilometers, the temperature may attain 1100 degrees centigrade. The absorption of solar extreme UV, which we call EUV, extreme ultraviolet, EUV radiation, and X-rays by oxygen and nitrogen, by oxygen and nitrogen. So, here oxygen and nitrogen which are present, they absorb extreme ultraviolet and X-rays, and nitrogen at these heights causes the temperature to increase. So, here oxygen and nitrogen are present, they absorb extreme ultraviolet and X-rays, that is why the temperature increases. These ionizing radiations, these are known as, these are the ionizing radiations, X-rays and EUVs. Then next is exosphere. So, that is the fifth layer, exosphere. Beyond the thermosphere is the exosphere. The air is extremely thin. So, air here is extremely thin, means the substances are present in very less amount. So, it is very thin layer, extremely thin, but there are some traces of gases. Some gases are present in traces, means in a very less amount in traces, and these are mostly halogens. The helium, neon, all these are the halogens as far out as 8,000 kilometer, up to 8,000 kilometer, that is the thermosphere. So, only halogens are present and this layer is extremely thin. The exosphere has no defined limits. Although I have said you 8,000 kilometer, it has no definite limit. So, exosphere has no defined limits, but fades out into the vacuum of space. Vacuum of space, it fades out there. So, there is no limit. Then the composition of the atmosphere. Composition of the atmosphere. Atmosphere is a mixture. Atmosphere is a mixture of gases, liquids and solids. So, it is a mixture of gases, liquids and solids. Its composition and conditions vary from place to place. It is not constant everywhere. It varies from place to place with altitude and through time, because whatever is the composition today, it may not be the same after 1 month. So, it varies with time from place to place and with altitude, the altitude. So, it is not same always everywhere. The atmosphere is primarily composed of two gases. The atmosphere is primarily composed of two gases, the nitrogen and oxygen, which contribute about 99% of its composition. So, nitrogen and oxygen. Other elements are also present, other gaseous substances, but nitrogen and oxygen, they contribute to 99% to its composition. So, rest is 1%. The balance 1% comprises a large number of gases. So, only two gases contribute to 99% and rest 1% comprises large number of gases, some inert and some chemically active. So, some are inert, the rest the rest 1%, they include two categories, some are inert and some are chemically active. The inert constituents have long lifetimes because they are inert, they are not chemically active. So, they last for long period, they have long lifetimes. Example, helium, neon, krypton, xenon. So, these are the inert elements, and chemically active gases have short lifetime. Those gases which are chemically active, they have short lifetime. Example is carbon dioxide, H2O, water, methane, CH4, sulfur dioxide, SO2, O3, ozone, etc. So, these are chemically active. So, they have the shorter lifetime, but inert gases, they have long lifetime because they are chemically inert, not active. So, they last for a longer period, and carbon dioxide, short lifetime, H2O, because they change their form, they are converted to other compounds. The atmosphere also contains minute liquids or solid particles. In the atmosphere, there is also presence of minute liquid or solid particles, which are collectively called aerosols. Which are collectively called aerosols. So, these are the minute liquid or solid particles. The atmosphere contains moisture to a varying degrees depending on the location, time of the day and season. So, percentage of moisture that also varies. It depends on the time of the day, season and location. Then atmospheric pressure. So, that is about the atmosphere. Then atmospheric pressure. Pressure means it is the weight of the atmosphere, and the gravitational pull of the earth. Gravitational pull of the earth means in Oriya we can say madhyakorsana shakti, पृथ्वीर जो madhyakorsana shakti, the gravitational pull of the earth keeps the atmosphere bound to it, means it remains bound with the surface of the earth because of the gravitational pull of the earth without allowing to escape into the outer space. So, it remains bound with the surface of the earth, and the main reason is the gravitational pull of the earth. The weight of the air per unit area above the surface is called atmospheric pressure. So, atmospheric pressure again you can say it is the weight of the air, per unit area, means per square centimeter or square meter per unit area, that is called as the atmospheric pressure. At sea level, the global mean pressure is 760 millimeter of mercury. (760 millimeter of mercury or 1 atmosphere). So, that is the pressure at the sea level, So, when you go higher up above sea level, the pressure will decrease, and if you go down below sea level, pressure will increase. So, that is the weight of the atmosphere per unit area, and the standard pressure, that is the at global pressure at sea level, that is about 760 millimeter of mercury. So, that is all about the atmosphere, and so next class we will study about the hydrosphere. So, that is about the atmosphere. Okay. So, thank you. In the next class we will study about the hydrosphere, means the water layer. Hydro means water. Okay.